Hi all, in this video we are going to see how to perform a data visualization using Power BI. So as you are aware, what is meant by data visualization? Data visualization translates common data sets into a visual format because pictures speak more than a word. So it can be easily understandable by the human brain. And there are some of the importance of the data visualization. You can understand the complex data by visually seeing the data distribution that will improve the decision making, and it is the effective communication of our insight to the other people, and you can identify some patterns and the trends available in the data. And you can have a different ways of representing the data visualization. That is, in Microsoft Excel itself, you can project with various charts and bars with your data, and we have Tableau and the Power BI and others. In my previous video, I have explained and showed the demo how you can do the data visualization with Tableau and Power BI. So Power BI is a business analytical tool which is mainly developed by the Microsoft. Power BI allows the user to visualize and analyze the data from the various sources which are coming from either an Excel sheet or from the SQL Server database or from the internet. So by getting these data, Power BI is used to create some interactive reports and the dashboard. Through that, it can share the insights across their organization in a visual format which can be easily understandable to the people. Power BI is widely used for transforming a raw data into a meaningful information which will enable you to do the data-driven decision making. And there are some building blocks available in the Power BI. The first one is the data set. Data set represents the collection of data which can be coming from an Excel sheet, because this is the main source of projecting the visualization. It can be collected from the Excel sheet or from CSV file or from the SQL Server or from text files too. And next is the visualization. So visual representation of the data can be represented in terms of pie chart, line graph and the bar chart and so on. And tiles, which is a single visualization area in a report or on a dashboard. Then reports. Reports represent collection of visualization that appear together on one or more pages. And finally, dashboard, which is a single layer presentation which provide multiple visualization. And this is the way how the Power BI environment will look like. And here these are called as tiles. And this is the entire dashboard. And whatever you are representing, you can have a page here. And you can create any number of pages by clicking here. And this will help you to see your visualization either in the desktop mode or in the mobile mode. And this is the area we have the filters that you can apply to the data to provide a dynamic interaction with the data. And then visualization, which contain all the relevant visualization tools which you can apply for your data. And the data, whatever you loaded, that information available, the data set will be available here. And here in the left side, we have the first one is the report view. The first one is the report view. And this one is the table view where you can see your data in a table format. And this is a model view which contain like a classes and property way. And we have some DAX query view. And now I will show you a demo so that you can have an idea how the results of a clustering algorithm can be integrated in a visualization tool using the Power BI. Not only clustering, you can have a data exploration or exploratory data analysis you can do with, or the classification results you can project in the Power BI for better visualization of your data. The environment I am going to use to show the demo for the clustering algorithm is the Jupyter environment. The clustering algorithm I am going to implement is the self-organizing feature map. And to work with the clustering algorithm, first we analyze the input data. The input data I am going to use is the iris.csv. and this having 150 instances, and each instance having 3 parameters, that is sepal length, sepal width, petal length and the petal width. So this is the input data. First we have to load this input data inside the Jupyter environment. So first we have to upload the data. So click upload, select the data file and then open. So the file get uploaded. To know about the clustering algorithm, the SOFM is the artificial neural network based clustering algorithm, which is an unsupervised learning algorithm. And to work with this algorithm, first we have to install the mini SOM. After installing the relevant Python library to implement the SOFM algorithm, next we have to import the required libraries, and here I have imported pandas, numpy and then mini SOM, which is used to implement the SOFM clustering algorithm, and standard scalar for normalizing the data. And the next step is we have to load the data set. So the file we have already seen, which having 4 attributes, and this is loaded and the initial 5 rows are displayed here, and the values whichever having a null values in the data set, and that is replaced by the mean imputation, and later the data are standardized using the standard scalar. And next we are going to define the information or the clustering algorithm or initializing the clustering algorithm, and here the number of clusters we are going to group the data as 3. So the grid size is given as 1, 3. It is a one dimensional with 3 clustered output. And if I want to create 4 cluster, then the grid size is 2 cross 2. And the maximum iteration we have to run the algorithm is 100. And for the mini SOM, we have to give the grid size, that is the row and the column, and then the shape of our input, the number of instances, and the sigma is the value which specify the radius neighborhood around the winning neuron, and the learning rate represent how fast the algorithm has to learn. And now we have to initialize the weight for this network based on the input data. After initializing, we are training the data by passing the input data along with how many number of iteration the algorithm has to take up. Now the model get trained with the input data with the updated weights. And the next step is we have to assign cluster number to the each data point. So every instance to which cluster it is a winning, that cluster number will be assigned to that particular instance. And here you can see the first instance is assigned to the cluster number 0 and the last instance is assigned to the cluster number 2. And now we want to display the updated weights in our neuron. So just we get the weight of the SOFM network and display the weight. The weight represent 3 things. It represents 3 clusters. Each cluster the 4 attributes weight. And the step 7, I am just going to plot it in a scatter plot by using the matplotlib and the Seaborn library. And here we have 3 clusters which will be given in 3 different colors, and the cluster centroid also represented with the different blue color. And once it is completed, basically you have 4 features. Now I want to visualize this clustering output inside the Power BI. So the resulted cluster column also added inside my data set. So that data set information, we have it here. That is the labels, whatever we got. We created a new column called as cluster that is added along with the data set with the previous 4 feature values. And now this information is saved in a file called as iris_cluster.csv. And this is the CSV file which is an input to the Power BI to do the visualization or to do the analysis of the clustering output. And now this file first I have to download. So I'll just go with iris_cluster I select the file and then I just download it and it get downloaded inside my download folder. Now I am opening the Power BI. So I just open with Power BI. So here first you have to load the input data. So get the data from other sources. So here I want to get the data from the CSV file. So connect it. Select the file what you want to explore in the Power BI. Open the file. So now it is connected and the data get loaded. You can able to see the 4 features along with the cluster label. And now we have to load the data inside the environment, and here the data get loaded. We can able to see in the right hand side the data with the 4 features and the cluster. And this is the area where you are going to do a report view, where you can drag and drop any visualization tool inside this in order to create a dashboard. And the next view is a table view. Here you can see all your input feature which is displayed in a table format. And next is the model view. There it will be the name of the file is iris clustered and what are all the features available, and that will be available as an instance of a class model. And now we will go to the report view. So in the report view, now I am going to have a scatter plot. So just double click the scatter plot. You will get the scatter plot here. And now I take one feature for x-axis, one feature for the y-axis to project all the data points in the scatter plot. So take the petal length for the x-axis and petal width for the y-axis. So here it is showing the sum of all the values in that particular column, but we need the data point distribution should be there in the scatter plot. So instead of displaying the sum, you just change to don't summarize. And same thing here also, put don't summarize. So you got all the data points which is projected in the scatter plot. So now for the 3 cluster, we need to give 3 different colors. We have a cluster label. So drag and drop and put it in the legend. So now you can see the 3 different cluster values you got out of it. So this is the desktop view. Suppose you want to see it in the mobile view, click it. It will be viewed in the mobile view. So this will show you the mobile view of the same projection. And now I will just go to the desktop view. And the next thing what I want to do is I want to create a bar plot. So I am going to specify the clustered column chart. So this chart I am going to keep the clusters in the x-axis and the features for each cluster. I am going to keep it as a bar. So for this I have to keep the x-axis is cluster and the y-axis all the features I am going to keep it. So every cluster I am going to give what is the average value of petal width, petal length, sepal length and the sepal width. So I am going to keep the average. So change the sum to average. So you got the average of all the values. So as you see here, and here the sepal length for the cluster 0 is average, it is 5.02, this is 5.50 and this is 6.46. And here it is petal length 1.47 and then 3.88 and then it is 5.66. Now I am going to apply a filter where I am going to show the clusters only with the petal length average value is greater than 5. So petal length, I am just going here, click this filter, going to tell greater than 5. So I am just going to put greater than 5, apply filter, so I will get only the cluster 2. So I want to show the clusters which are having this petal length average is less than 5. So I just change it to less than 5. Then apply the filter. So you got cluster 0 and cluster 1, which having the average petal length is less than 5. So that you can apply the filters. So if I want to remove, I can just remove it here, or if I select the particular cluster, I can have a dynamic change in my scatter plot also. Only the cluster 1 get highlighted here. You want to remove it, you can just remove it. So now the next plot I am going to use it is the single bar plot. So I just select one bar. So here I am going to have the x-axis is the cluster and y-axis is any one of the feature. So I am going to keep the average of the feature. So you can see here for the cluster 0, what is the average petal length, and average petal length for the cluster 1 and the cluster 2. So you can apply all your filters so that it can be applicable to all your tiles available inside your dashboard. So the next visualization I am going to use the table. So just click the table and you can just drag and drop what you want to keep it in that particular column. So here it is petal length, petal width and the cluster. So instead of having the sum value, I want to have the data distribution. So change to don't summarize and don't summarize. So now I want to apply a filter here. So I want to have the clusters with only the cluster 0. So I can apply a filter here, and here I can tell I can keep the cluster which is greater than 1. So apply filter, so it will display only cluster 2. So if I select anything here, only the cluster 2's data alone get highlighted. So if I remove it, so all values will be there. If I select anything here, so I can apply more than one constraint also inside this filter component. For example, it is 2 and along with I want to maintain the petal length is greater than 4. So I can go with petal length which is greater than 4. So apply filter. So here cluster 2 with petal length greater than 4 alone get displayed. So I can apply more than one constraint through the filter and I can dynamically change the visualization inside the dashboard by doing this analysis. Suppose you want to change the color of the graph representation. So for that what you have to do is the default color representation is here. You want to change the color format. You can change the colors here with the different variations. And the next thing, instead of this data point, I want to change the representation of the shape of the data points. Then I can go with here. I have markers. In the markers, I tell the shape I need is the triangle type. So all my data points will be represented in a triangle type. I want to display the data point values of each bar. Then I can go with select this tile and then you can select it here, change the data labels. So you have the values of the data label will be displayed along with the data bar. For every bar the equivalent value will be displayed there itself. And there is another one advantage while using your Power BI, that is you can execute Python code also inside the Power BI and the results of the Python code you can explore inside the Power BI visualization dashboard. So to start with, I will just go with a new blank report. So previously I have executed the code in the Jupyter, and the results of the CSV file I have explored inside the Power BI. So now I am going to execute the SOFM clustering also inside the Power BI itself, and directly the results I can extract and visualize in the Power BI dashboard. So to do that, I will get the data source. So now the data source I am going to get is the original source data. That is the iris.csv, which contain only 4 columns with 4 features. And I just open it. Once I open, instead of loading the data, I want to transform the data. So during the transformation, I can either write a script with R code or with the Python code to do any clustering or classification algorithms I can apply in that particular data set. So the data set get loaded here inside the Power Query Editor. And here I can go with the option called as transform. Here you can see you have 2 options, running the R script or running the Python script. So to make your Python script to be executed inside the Power BI, initially you have to ensure the path of your Python file loaded inside your system. So you go to File, you go to Option and Settings, and in the options you have to just configure the path of your Python scripting. And here the Python files are installed inside the E drive Anaconda. So I have selected that and I have fixed that path for executing my Python script. So click OK. So any of my Python script can able to run inside the Power BI environment directly. So I can go with the query editor and here I choose my run Python script. So whatever data I am having here, defaultly it will be available inside the variable called as data set. So if I want to access the sepal length, sepal width, I can use this data set to access it. So I have already have the code, whatever I have executed the same thing, so that I have kept it here and I am going to copy and paste it here. So now you can see here what are the information available. The first thing I uploaded or imported the relevant libraries needed, and after that similarly our PD from the pandas library using a data frame from the data set, because defaultly whatever I have uploaded from the CSV file, it is available inside the input variable data set. So take every attribute of it and store it in another variable, that also I am using a same name data set. So the CSV file which represent in a table format, now it will be loaded in the data set variable. And the next step, if there is any null value, I am doing the imputation using mean. And here I am going to do the z-score normalization. Since standard scalar, if I am using, it's showing some error in loading the sklearn. So I have used the z-score normalization. And remaining all the steps is similar. First, we have to initialize the output layers, that is the grid with 1 cross 3 for representing 3 clusters. And initialize the minisome with the input grid with 1, 3, that is the output size of the grid 1, 3, and the input size of your data, then the radius of the neighborhood and the learning rate. Then initialize the weight, then start the training with the input data with the number of iteration. And after the training is over, every instance assign the winning cluster label, and that cluster label you store it in a new label called as cluster inside the same data set. Once you click OK, this will enable the Power BI to run the Python script. So click OK, the script get executed. It is asking some data privacy. So click continue, ignore, click save. So you can see automatically along with your 4 columns, now the cluster column get incorporated inside your data set. You see here the 4 features along with the cluster column which you executed in the Python script. If I want to edit the script, I can just double click, the script will open, I can edit it, whatever changes I want to make, I can make it here. So now this information I want to pass it to my Power BI visualization part. So for that you go to click home, then you can click this option here, close and apply. When you click close and apply, the data set whatever we created, the result of our Python script, which is loaded in the data area. So we can wait. Now the data get loaded. You can see here the cluster label, all the 4 features get loaded here. So instead of executing the clustering algorithm in the Jupyter environment, then passing the result inside the Power BI, directly you can execute any machine learning algorithm using the Python script editor. You can execute here itself inside the Power BI environment, and you can integrate the output of that inside the dashboard environment for the visualization. So here I just use the scatter plot. Click the scatter plot and then drag and drop any 2 features and change the features to don't summarize. So it will get the data points. Then take the cluster, pass it to the legend. You will get different colors visualized here. I hope you got a clear idea how you can visualize the output of any machine learning algorithm inside the environment of the Power BI by creating dashboard with different visualization tools. Thank you.